Okay, so 5.1 is all about variation functions. Today we're going to solve problems involving direct, inverse, joint, and combined variation. So in defining direct variation, we know that this is going to be a relationship between two variables x and y, and this is going to be our equation, y equals k times x, okay, where k cannot be 0 because the variable k is going to be the constant of variation, and if k was 0, there would be no variation. So k is going to be the variable that relates your x and your y together. Notice that this equation is linear. Okay, can anybody tell me how we know this is linear? Okay, because the variable's to the first power. Good. Okay, so it's x to the first power, so this is going to be linear. And then it says, what is the slope in the y-intercept? So we know that the slope is always in front of the x term, so our slope would be k. And when I say m equals k, do you guys remember that m is the variable for the slope? Okay, so that's just the slope is k. And then the y-intercept is 0 because we don't have anything added or subtracted to the end. So your y-intercept is going to be 0. Now, why do you think I'm talking about that this is a linear function and what the slope and the y-intercept are? What are we probably going to do with some of these functions? Yeah, we're going to graph them, and in order to graph them, we're going to have to start at the y-intercept and use the slope to find the next point. Oh, look at this. Given y varies directly as x, write and graph each direct variation function. So you're given your y and your x. If you have to find the function, actually, I'm going to do this part fresh with you. And if you guys want your straight edges, that'll be awesome because if they're linear, our graphs are going to be straight lines. Okay, so our first step to write the equation, remember that our equation that we just wrote down is going to be y equals kx. It's actually just in the box above here, right? We have it in our box, the direct variation. So what we have to do is we have to find what our k value is. So for step 1, we're going to find k, and we're going to do that using our y and our x. Okay, so if y equals kx, I'm going to plug 6.5 in for y. I'm going to plug 13 in for x, and now all I have to do is solve for k. Right? So, Timmy, what am I going to do to solve for k here?
Divide 13.
Good, okay. Do you guys know what 6.5 divided by 13 is without using your calculator?
2.
1/2, okay? Yeah, because, well, no, I know what you were thinking, right? Yeah, 13 divided by 6.5 is 2, right? So it would be 1/2. No, that's fine. Okay, so then your k value is going to be 1/2. Now, to write your equation, what you're going to do is substitute k into your equation. So your equation is y equals kx, so this is y equals 1/2 x. Okay, so this is our equation. Why don't I have numbers in my final equation? Anybody tell me that? Okay, so both of your answers are going to get us to where we need to go. The equation has to represent all of the points on the graph. How many points does this represent on our graph? 1. Okay, but it's a linear function. And how many points are on a graph of a linear function? How many? Yeah, an infinite amount of points, right? So we're going to use this to graph. Okay, so to graph, bless you. So to graph, you're going to start at your y-intercept, which, what did we already say our y-intercept was? 0, okay? So your y-intercept is going to be 0, 0. It's always going to be 0, 0 because you're never going to have anything added to it. And then to find your next point, you can use your slope. So use slope to find other points. So 1/2. Okay, so I'm going to start at 0, 0. And actually, I'll do this in a color so that you guys can see that a little better. And I'm just going to label, so that whoever is looking at my graph knows that I went by ones as my unit. And then it says to use my slope. So the slope is the rise over the run. Do you guys understand what that means? Okay, so I'm going to go up how many? I'm going to go up 1, and then I'm going to go over 2. And then your over, if it's positive, is to the right. If it's negative, it would be to the left. So if I want to see what happens over here, I don't have to go up 1 over 2. What else could I do? Down 1, left 2. Because it's like I'm doing a negative over a negative, which a negative over a negative is a what? Positive. Okay? And then if you guys have the straight edges that I gave you, you can use that. If you don't have the straight edge that I gave you, the side of a piece of paper works well. What's that? Okay, great. Okay, so now what we're going to do is start to apply these to real life situations. So it says the cost of an item in euros E, okay, varies directly. So I'm going to highlight that varies directly because that's going to be important. So it varies directly as the cost of the item in dollars D, and E equals 3.5 euros when D equals $5, and we're going to find D when E equals 10 euros. Okay, so this says E varies directly as the cost of the items in dollars D. So this is going to set up your equation for you. Okay, so that's what we're going to do first. So direct variation equation. If it says E varies directly as D, our equation is going to start with E, and then what's always going to be our constant value? What's our constant variable? Yeah, K. And then if it varies directly as D, it's going to be euros equals the constant K times D. Do you guys know what euros are? It's the currency used in Europe.
Sandwich.
Have you guys ever used some euros?
Yeah.
That's a gyro. You're going to?
Yeah, I'm going to France.
Are you going with the school? Oh, awesome. That's really awesome.
Actually, I actually just found out that it's spelled gyro, but it actually is pronounced gyro.
Euro, okay. Yeah, it's Greek, right? Okay, so what we're going to do now is we have to solve to find what? Nope.
D.
No. What did we find first in the last problem? K. Okay, so then we're going to find K. All right, so if we're going to find K, I have to look at what else was given. It says E equals 3.5 euros when D is $5. Okay? Now, it also says find D when E equals 10 euros. So this is where it can get confusing. I have 3 different values. How do I know which one to plug in for which? So notice how this is in the same sentence where it says this is the amount of euros when D is this much. When they give you a pair, that's what you're going to plug in together. Okay? So do you guys see how what I highlighted in pink, that's going to be a pair because it's given together? It says E is this value when D is this value? Yes or no? Okay, so then what we're going to do is we're going to plug in the 3.85 in for E. And the dollars would be 5. And we're going to solve this to find K. All right, so we're going to divide by 5. And yeah, Hunter, what'd you get?
I got 7.7.
That did you get? It should be .77. I think you just moved your decimal here.
Oh wait, no, I was on the second part. I got .77 for the first one, and then when it equals
Oh, okay, so I don't think that part's accurate, but we'll look at it. Okay, so yeah, your K is 0.77. So now what we're gonna do is write our equation, okay? So we're plugging that back in here. So our equation,
She's actually right. When you plug it in, you get 7.7 cents.
I think you should get 12.99.
What?
Okay, so when you write your equation,
Yeah, I got the wrong one.
as I know some of you are ahead, and that's awesome.
Oh, when E
Oh.
equals $10.
This logo, could you just use it for
Yeah,
promotion?
we went from
Okay, so it tells you that, in a lot of cases it'll tell you to actually write your equation. So I do want you to write your equation. That's how it'll look on your quiz as well. So this is going to be your equation. And then it says to find D.
12.19.
When E equals 10 euros. Oops. Not that.
What was it?
Okay, so then what we're going to do is we are going to substitute 10 into our equation and solve. So, yeah, did you guys plug it in for D?
Yeah.
Okay. Yep. So then we'll just divide. And then, Hunter, what did you get?
12.98.
Okay, good. So when you're rounding, first it's dollars, so we know that we're going to round to the nearest hundredth. And for D, if you got 12, you got 12.98. What was the number after it? It was 7? Okay, so then that means that 7 will round it up, so then your final answer will be 12.99. Okay, and then some of you probably tried it before me, like Marisha. And Marisha, how did you set your problem up?
I did 3.85 over 5 equals 10 over x.
Okay, yep. So I'm going to just do the or. You can solve this way. So you have 3.85 euros when D is $5. And then that would be equal to 10 euros. And then I'm just going to call this X dollars. And then you can cross multiply and solve. So 3.85x would equal 50, divide by 3.85. And you got 12.99, right, Marisha? Okay, great. All right, so example 3. Find the perimeter P of a regular dodecagon. Oh, it says the perimeter P of a regular dodecagon. Do you guys remember what a dodecagon is from geometry?
10.
Not a dodecagon.
Is that 11?
Nope.
12?
12. Because the decagon is 10, and then the dodecagon will be 12. So P of a regular dodecagon. Do you guys remember what regular means?
No.
Regular means there are no weird angles.
Yeah.
They're all equal?
Yes, all the sides are equal and all the angles are equal.
I don't know how that works.
It is for me.
Some nightmares from geometry.
Yes, I'm gonna have next
Yes,
year.
Marisha and I had very,
So for this one, the perimeter of a regular dodecagon varies directly as the side length S. Make sure that you do know how to write the equation because that is something that you're going to have to do on your quiz, which is why I'm showing it here to you now. So you're going to have P varies directly as the side length S. So the first thing I would do is I would just write the equation in variables. And you need to understand that you're always solving for what? You're always going to solve for K first. So that's always going to be your first step. So they give you another pair that P is 18 inches when S is 1.5 inches. So we're going to go ahead and solve for K. So I have 18 inches for P. I have 1.5 inches. We're going to divide each side by 1.5 to find our K value. And Timmy, what'd you get for K for this one?
12.
Good. Okay, so then we're going to write our equation. equation is going to be P equals 12S. So then, when we're doing our last step, which is find S, when P equals 7.5 inches, I can plug in 7.5 for P and I can solve for S. Now sometimes, like the last two, we've actually had to solve to find S. Other times you'll just have to evaluate, you'll just have to multiply, and that just depends on what you have. And we'll do 75 divided by 12, which, let's try to do this with mental math. Okay, so do you guys know what 12 times 5 is?
60.
Okay, good. Okay, so 12 times 6 would be what? 72. Okay, so, and, but Marisha, how'd you do that so fast?
It's 96.
That was added 12?
Yeah, you just add 12, right? If you know 12 times 5 is 60, then you're just adding 12, so it'll be 72. So that means that 12 goes into 75 how many times?
12.
Okay, so it goes in there 6 times evenly. Okay, and the reason why it's 6 is because 6 times 12 is 72, and then 75 minus 72 is going to be what? 3, so this would be 6 and 3 over 12. What is 3 over 12 reduced to? 1/4. Okay, so because you're dividing both of them by 3. Okay, so it would be 6 1/4 inches, or 6.25 inches. Okay, I'm trying to get you guys prepared for that SAT, that PSAT that's coming up for you.
I get bored halfway.
Before spring break.
All right, let's keep moving.
Isn't that the week before spring break?
No, it's the when you come back.
What? No!
Yeah.
Why?
All right,
the
we're
week
going
before
to keep moving along here, and we're going to talk about our next one. So we just did joint variation, or sorry, we just did direct variation. Guys, I shouldn't have to compete with you talking. Your joint variation is going to be the next one. So if it says that y varies jointly, that means that you're going to have two variables. So notice it says y varies jointly as x and z. Okay, so you're joining two variables together. So this is going to be your equation, and the variable k is still going to be the constant of variation, but then let's write our equation in this box. That way when you guys come back to your notes, you're going to see all of the equations are in those boxes, so you know what to use for each one. Okay? Okay, so let's take an example from this one. So the volume V of a cone varies jointly as the area of base B and the height h, and V, the volume, is going to be 12 pi feet cubed, when B, which is the area of the base, is 9 pi feet squared, and h is 4 feet. Find B when V equals 24 pi feet cubed and h is 9 feet. Now there are a lot of numbers in there. Okay, so we're going to break this down and do it a little bit at a time. So first, notice whenever you have the volume, what is the units on our feet? Cube. Do you guys know why that is?
Because volume is cubic unit.
It is, but can you guys rationalize why?
Because it goes everywhere.
So think about, do you guys know the volume formula for like just a box?
Fire times
Base times height.
Yep, times length. So it's length times width times height. So think about units. If you're multiplying feet times feet, or x times x times x, it would be x cubed. That's why the feet are cubed. Same thing for this b, okay? Your b is in feet squared because it's area, because you're taking two units and you're multiplying them together. All right, so then let's just do this one step at a time. So your first step is going to be to do what? What are we going to find first? Yeah, well, okay, let's write our equation. Okay, so the volume is going to equal, I'm going to do this part with you. Okay, so your volume is going to equal, the volume varies jointly And I'm going to highlight this part. So the volume V of a cone varies jointly as the area of the base B and the height H. Do you guys think that you can write your equation based on that information? I think you guys can. Give it a try. Okay, and you can use your equation above to help you. Okay, Grace, tell me what you're thinking.
I'm not thinking.
Okay, so let's think. All right, so Grace, what's one thing you know has to be in the equation? No, so we're just gonna write it with variables first. Okay, so just with variables. So what variable has to be in there? Okay, so yep. So the volume V varies jointly. So I'm gonna start with V equals what variable has to be on this side? Okay. Yeah, B, H, and K, right? Okay, so it's K times B times H. Yep, you got it. Okay, and then what we're going to do is we're going to find K. And then to find that, those are the values that I gave you. So I gave you that the volume was 12 pi feet cubed. So that's something that we're going to have to use. I gave you when B is another value and when H is 4. And B was 9 pi feet squared. Okay, so the volume was 12 pi. We're trying to find K. B was 9 pi and H was 4. Okay, now, do you guys know how to multiply? We're not going to do decimals. Do you guys know how to multiply 9 pi times 4? Yeah, Alex?
I'm actually just curious. I know lowercase b is like just the length of the base, and uppercase b is the area. But what is an uppercase h?
That, I don't know. I don't know that I've seen an uppercase H. That, yeah, but they do use the capital. They do use the capital B as the area.
Yeah, I wasn't sure if there was something equivalent.
Do you think you could tell me what this is? No
Isn't
decimals.
that like 36 pi?
Yeah, exactly, 36 pi, right? So all you have to do is multiply the 9 and the 4 together. So this is 36 pi times k. If I want to get k by itself, Arandi, what do you think I have to do to both sides? Understand? Yeah, divide by what?
36?
Yep, and what else? Yes, okay, so we're going to divide by the 36 and the pi. So then what happens to our units of pi here?
Can't fall out.
Yeah, because what is pi divided by pi?
No pi.
No, not 0. 1, okay? And then we have 12 over 36. What goes into both 12 and 36?
3.
3. So what's a bigger one?
4.
What's a bigger one?
12.
12. Okay, so if you divide by 12, it'll be 1 over,
3.
no, because you divide by 12, right?
3. Nice job.
And the last one's question.
Okay, so your K value is going to be 1/3. So now when we're writing our equation, okay, our equation is V equals 1/3 B times H. Okay, so area of the base times the height. Okay, so then our step 2 is going to be to find B, and it says find B when the volume is 24 pi feet cubed. So go ahead and try to solve that without your calculator. You can do it. Okay, and, we're going to actually plug in the K. So we have 1/3. We're trying to find our B. and it says h is 9 feet. Yeah, Alex?
Is B 2.3?
Were you telling me what you did first?
Oh, okay. I set it up 24 pi equals 1/3 B times 9.
Okay. Yep.
Multiplied 1/3 by 93.
Okay, good. So if you guys haven't done that yet, you can multiply your two numbers together, just like Alex did. And really, 9 times 1/3 is the same thing as 9 what?
Divided by 3.
Yeah, okay, so, okay, go ahead, Alex.
And then it was 3B. 24 pi equals 3B.
Yeah,
And 24 pi divided by 3 is 3 pi.
good. Is what pi?
Is 8 pi.
Perfect, okay? So then your final answer is that B is going to be 8 pi, and then we'll just label it with our units. So in this case, this the big B represents the area. So then what are my units going to be?
Feet.
Good, feet squared. Very good. Okay, nice job. Okay, so for example 5, we have a lateral surface area L of a cone. And I can draw you a picture too to see if you guys remember this from geometry. Of a cone, and that's going to vary jointly. So it says L varies jointly as the base radius R, and the slant height, which is this fancy L. Okay, so when you guys read that first sentence, are you able to come up with an equation, you think?
No.
A little bit.
Okay, let's try that first. Before we even go on, let's try that part first. Okay, Gabe, want to tell me what you got?
What?
I said, do you want to tell me what you got
For what?
for what I just asked you to do? I asked if you could find the equation that's going to relate all of our variables together.
You're asking me for the L equals
Yep, the L.
times R times L.
Good, the L equals, and say the rest of it again.
Okay.
Yep.
Times R times the lowercase L.
Yeah, perfect. Yep. Okay, and then for this, your L value is going to be 63 pi meters squared. When R is 3.5 meters and the slant height is 18 meters. And then we're going to find R to the nearest tenth when L is 8 pi meters squared. Okay, so Joe, what are we going to do first for this problem?
I don't like this stage.
Say it again, I'm sorry. And what are we trying to find? Yep, okay, so we're going to plug in our variables and we're going to try to find K. Okay, so to find K, Hunter, can you set up the equation for me? So what would I plug in for L?
You would, well, you zoom in this first. Okay. So.
You should have it written down.
For L, you got, 18 meters, or wait, no, 5 meters.
Nope. So do the uppercase L first, right? Because that's what we're going to plug in first. And what did you say we plug in for that?
63 pi.
Yeah.
M squared.
And then, yep, and then that'll be the units. Okay, and then what am I going to substitute in for? I don't substitute in for K because that's what I'm finding. But what is going to be my radius and slant height?
3.5 meters.
Okay.
And, the slant height would be 18.
Yep, yep. Okay, and then so what we're going to do is plug those in, and then when you're multiplying, we're going to multiply by these first. Okay, so we're going to do 3.5 times 18. Did we already do that?
63.
Okay, good. So you're going to get 63K. So we're going to divide by 63. Now, we know that anything divided by itself is 1. So 63 divided by 63 is going to be 1, but what am I going to be left with?
Pi.
Yeah, good, okay? And so that is exactly what I'm going to plug in.
Is pumpkin?
Are we celebrating Pi Day? It's like
Probably not.
It's part of my religion.
Okay, so then L is going to equal pi, and then R, and then our lowercase l. And then, so what we're going to try to do here, and this is our equation, is now we're going to find R to the nearest tenth when L is 8 pi and the slant height is 5 meters. So see if you guys can do that. Notice that it says to the nearest tenth.
Excuse you, Heidi.
Okay, so how are we doing on this?
Good.
All right, so then, Arandi, did you already finish this? Good. Okay, so then, Hunter, what are we dividing by for this?
5.
And?
Pi R.
Nope, just,
5 pi.
yes. Okay, so don't divide by the variable. But then what happens to the pi's? Okay, those are going to cancel. Now the rest of this, we can actually do this in our head as well. How many times does 5 go into 8? One time with how many left over? 3. So this would be 1 3/5. Do you guys know how you can turn 3/5 into a decimal?
Divide 3 by 5.
0.6.
Do you know how you can do it without a calculator?
Point
So-
6 times it by 2 whatever that is.
Yep, you can multiply it so you get to one of the places. So the first place as a decimal is the tenths place. The next place would be the hundredths, etc. If you multiply 5 by what would you get 10?
2.
It'd be 2, right? And then so on the top it would be 2. So this is the same thing as 1 and 6 over 10. How do you write 6 over 10 as a decimal?
0.6.
Good. Okay, so R is going to be 1.6 meters by 2 over
That's
2.
what I did, Caitlin.
Wait, this isn't gonna be no calculator test, is it?
You know how hard I struggled on that question? That was like 6 times 4.5.
For honors, I make them do it no calculator, but I'm
I'm
not gonna make
so I need
it.
a
I'm not.
Normal, I would
Okay, so I'm just gonna draw a picture of this for you. So your radius, your radius is of the base here.
No.
This is your slant height, and then this is your actual height, which is from here. Everything is related. We are all in the circle of math. Okay,
Circle of English.
let's go to inverse variation, which is our last type of variation that we're going to learn today. And for inverse variation, the relationship between two variables where y varies inversely as x is represented by this equation where it's y equals k divided by x. And again, you can't have your k value be 0. And then we're going to put that in our box. So when we're looking back, we can find all of our equations very easily. Okay, so y is going to be k over x, where k cannot be 0. And then y is going to equal k over x. And this is called what variation?
Inverse.
Inverse. Okay, so if it's direct, you multiply the k and the x. If it's joint, you multiply the k, the x, the y, or z. and in inverse, you're going to divide the k and the x. Okay, do you guys have all that copied down? Okay, so for example 6, it says that it's given that y varies inversely as x. We have to write and graph the inverse variation function. Notice here that it says we do have to write the function and graph it. Okay, that's why we're practicing writing out our function for all of those. Okay, so y equals 4 when x equals 5. For step 1, you're going to find k using y equals k over x, which this stuff should look a little familiar to it, because this kind of looks like what that you did today. Your warm-up. Your warm-up. That'll work. Because it's work you do with the bell. Okay, so if you want to solve this, Alex, Dirksen, what do we do to both sides to solve this? Okay, so when you multiply by 5, is if you're dividing by 5, you're going to get 1. So those cancel. And then so our k value is going to be what? 20. Okay, so it says to write the equation. So if you're writing the equation, what is the only number you're going to have in your equation? 20. Okay, so that is something big that sometimes people forget. Your equation should always have a y and an x, because every single function has to have an input and an output. If you plug in numbers, that only represents what?
1 point.
Yes, good. It only represents 1 point on your graph. Okay, very good. Now, for this one, we're going to graph by making a table. Actually, we're going to make 2 tables. So I'll say by making a table of positive values and a table of negative values. And I'm going to tell you why in a minute. Okay, so we're going to make 2 tables for this. So we're going to graph by making a table of positive values, and we're going to graph by making a table of negative values. And I'm going to show you another way that you can do this really easily without using your calculator. So this is our equation, y equals 20 over x, okay? Now, we want to make two different equations, 2 different values of tables for the same equation, because this type of graph is going to have 2 branches on it. Okay, so your graph, and actually we'll write this note up here. Okay, so this is going to have 2 branches, is what we call them, on the graph. And once we graph it, actually maybe one of you knows what this is called. Maybe, maybe not. What is it? No?
Linear.
Oh, you said a row. I was really confused.
A wrinkle.
None of the above. Okay, so
Start with
It's an
H.
exponential.
It starts with H.
horizontal.
hypotenuse.
no, but that is a math word.
Hyperbola.
Yeah, it's close to that. It's a hyperbola.
Oh,
Hyperabola.
Isn't that an English term?
Hyperbole is.
Hyperbola.
Okay, so let's talk about how we can plug our values in so that we don't have to use our calculator. So notice that whatever I plug in for x, do you guys see how I'm going to do 20 divided by that? So what are some easy values I could plug in? Okay, I could plug in 1. Now if I do 1 divided by 20, that's going to be kind of high on my graph, but usually I will do 1. For this one, I won't plot that just because it's really big. But what's another number that will be good?
4.
Okay, so 2, and we'll do the negative graph first. Yep, I heard 4 and 5. What's another good one? Let's do one more.
6.
10.
10. Okay, Let's talk about, can anybody tell me why 6 would not be an easy value to do? Okay, good. Okay, so if you are substituting this into your function, y equals 20 divided by negative 2, 20 divided by negative 2 is what? Negative 10. Okay, 20 divided by negative 4, negative 5, negative 4, negative 2. Yeah? Okay, so now what we're going to do is the same thing, but with our positive values. So if you divide 20 by positive 2, you get
10,
10.
5, 4, 2.
Beautiful. Okay, so now we're going to graph these. So this graph already goes out to 10, but I'm just going to label the ones that we're plugging in just to make it easier to graph. So 4, 5, 6, 7, 8, 9, 10. And this would be negative 2, negative 4, negative 5, 6, 7, 8, 9, and 10.
I think you would have been okay.
I don't think so.
That's okay. You don't need a hand.
Okay, so guys, I want you plotting your points.
Oh, so it's like a parabola, it's like cut it in half.
It's it actually, it kind of looks
It
like
goes like this,
it'll be like
like
a
two
curve.
exponential functions back to back.
They'll be crisscross from each other. Okay, so if you graph negative 2 and then negative 10, you'll have a point here. And then negative 4, negative 5. And then negative 5, negative 4. And then negative 10, 2. Okay, so see how I have these 4 points graphed? And then I'll show you how we can connect them. Okay, because we're going to connect them with the curve. Oh, good. Some of you guys already did it right. Okay, so I'm going to show you how we're going to connect them. So first I'm just going to do this branch. All right, and then I'm also going to connect it through this. And those are going to continue in that motion. Now, you'll notice on this graph that the branches are in quadrants that are directly across from each other. That will always happen. So, for instance, you could have one in this quadrant. Do you guys know what this quadrant's called? Nope. Second. It goes 1, 2, 3, 4. So, 2 and 4, they could be in those quadrants, or they could be in 1 and 3.
Any of them.
But they always have to be, like across from each other there. Oh, here. You guys need me to just put it up for me. Okay, so those are your 2 branches. How do our graphs look?
Good. Like a reflection.
Okay, great.